Alright, we went over 2 problems in class from the homework, and they were number 45, let's do that one first. G of x is equal to log base 5 x plus 1 over x. It says find the domain. So whenever you have a logarithm, this argument here has to be greater than 0. If you solve that inequality, that will tell you the domain. So how do you solve an inequality like this? You make a number line. What makes the top or the bottom 0? Negative 1 and 0. Neither is going to be part of the solution. And then you test. Think of a number bigger than 0. Like 1. Plug it in. 1 plus 1 is positive. 1 is positive. Positive over positive is positive. And how come they alternate? Because they both have odd powers. And since it's greater than 0, we shade in the plus ones. And there you go. That's what your number line for the domain looks like. So when you write your final answer, you can either write x such that x is less than negative 1, or x is greater than 0, or you can write negative infinity to negative 1, and then 0 to infinity. So the key to finding the domain is whatever this is, that has to be greater than 0. You solve what you get. And then, number 32. Log base 5 of the cube root of 25. Now this is one of the harder ones. It doesn't come out to a whole number. So like I told you guys, call that x. Whatever this number is, we're going to call it x. And then, once you have logarithmic form, you change it to exponential form. So this means the same thing as 5 to the x power equals the cube root of 25. And the only way you can solve this is by making a common base, right? Because isn't 25 the same thing as 5 to the second power? And then cube root means 1/3 power, right? And then you use your properties of exponents. You multiply the exponents, so you get 5 to the 2/3. So if 5 to the gorilla equals 5 to the banana, then gorilla equal banana. And there you go, that's your answer. So the key to this whole next 2 sections is, again, if you have log form, log base b of a equals c, you change it to exponential form, b to the c equals a. Or if you have exponential form, you change it to logarithmic form. So like I told you guys last time, just switch back and forth between the 2 and you should be successful at logarithms. Now tonight's homework, you're going to have to draw some graphs. Okay, but what I did in class is I made it simpler for you guys. So anytime you're graphing an exponential function like 2 to the x, 3 to the x, e to the x, whatever, 10 to the x, 5 to the x, okay? This is what I want from now. Instead of you plotting, I told you guys to plot 3 points, all I want now is 1 point. 0, 1. Right? Because if you plug in 0, 2 to the 0, 3 to the 0, e to the 0, 10 to the 0, it's all 1, right? But you got to remember that the x-axis is going to be a horizontal asymptote, so it's going to look like this. So this is what the graph looks like if the base is bigger than 1. If the base is like a fraction between 0 and 1, then the graph is going to go the other way. It's going to go like this. So if the base is bigger than 1, you have exponential growth. If you have something like 1/2 to the x, then you have exponential decay. Okay, but most of the problems you're going to see are going to look like that. So all I want is plot the point 0, 1, and whoa. Now, what would the inverse of these graphs be? Remember, a logarithm is the inverse of an exponential function. So the inverse of this is y equals log base 2 of x. The inverse of this one will be y equal log base 3 of x. The inverse of this one would be y equal log base e of x. But remember, when you have log base e, we just write ln x, which is natural log x. Anyway, these are inverses of this one. So since the exponential function has the 0.01, then the inverse is going to have the 0.10. And that's the point I want you to plot. And then all you have to do is do this. And see how it's symmetric about the line y equal x? So anytime you're graphing an exponential function, then 0, 1 is the key point. And for a logarithm, it's going to be 1, 0 because you have to switch to x's and y's. So tonight, this is what you're going to be doing. You're going to be graphing things like this. Y equals log base 2 of x minus 1 plus 3 or something. Okay, so you take the base graph, which is this, right? And then you're going to shift it 1 to the right and 3 up. So the key point is 1, 0 right here. I have to shift it 1 to the right and 3 up. That's the key point. But then also, this vertical asymptote here is also going to get shifted 1 to the right and 3 up. Now you can see when you shift it up, it really doesn't matter, but it has to shift 1 right. So then it's going to be like that, right? Here's the key point. So the graph looks like this. That's all you got to do. It's quite simple. Okay, let's do one more example of that. How about y equal log, no, let's do natural log. Natural log of x minus, let's go x plus 2. Okay? So remember, natural log means log base e of x plus 2. But it really doesn't matter. Your base graph, I just erased it. The base graph is going to pass through the point 1, 0, and see how the y-axis is on vertical asymptote? So all you have to do is shift the graph 2 to the left. So this vertical asymptote gets shifted 2 to the left, and then this point 1, 0 gets shifted 2 to the left, and then you simply go. So when you get to pre-calculus and calculus, that's all we want. We want a quick sketch. Okay, and then the last part of your homework, you have to solve equations. So let me take 2 problems from the book, number 90. Log base 3 of 3x minus 2 is equal to 2. Well, again, switch back and forth between these two and you'll be fine. So if you're given log form here, you change it to exponential form. So this means the same thing as 3 to the second power is equal to 3x minus 2. And once you do that, you get algebra 1 right here. So this is 9 equals 3x minus 2. Add 2 to both sides. 11 equals 3x. Divide by 3. X equals 11 thirds. Done. And then the other problem we did in class was 102. E to the negative 2x plus 1 is equal to 13. So this is exponential form. Then we're going to change it to log form. And notice the variable you're trying to solve for is in the exponents. That's the whole principle of logarithms right there. How do you solve equations when the variable's in the exponent? Okay, so here we go. So change this into log form. So this means the same thing as log base e of 13 is equal to negative 2x plus 1. Right? Because if you went backwards, you would go e to the this equals that, right? Which is this, so you just go backwards. But remember, when you have log base e of 13, we don't really write it like that. That's natural log 13. You have to get used to that. Hopefully after a while, you can just bypass the step and just write this. Okay, and then now easy. Now this is a number now. Don't get confused by this, because this is a number that can be punched in on your calculator. So you treat it just like any other number. So first step, subtract 1 from both sides. And then divide by negative 2. Now some of the class said, Mr. Park, isn't that natural log 12? No, that's because you have to do that first, right? Order of operation. So you have to compute what natural log 13 is. You can get that number on your calculator if you want. Subtract 1 and then divide by negative 2. And that's your answer. So tonight's homework, not too difficult. All right.